The next thing that can go wrong in a titration is using the wrong indicator. Now, in VCE chemistry, you're basically going to be mostly looking at weak acids reacting with a strong base, or weak bases reacting with a strong acid. In that case, we need to take a look at what actually happens during these titrations. So this is an example of using or titrating a carboxyl acid, which is a weak acid, with a strong base like sodium hydroxide. The pH range, when I do this equation, is obviously I'm starting off with a weak acid, so it's sitting here around about 3 or 4. It gradually changes as I add in sodium hydroxide until I get to a tipping point where all of a sudden it shoots up and skyrockets and my pH changes dramatically with a small amount of sodium hydroxide, and that's where you can see the equivalence point here happening. Obviously, if I keep on adding sodium hydroxide, it pushes up to around about 14, where my strong base sits. What we need to be sure of, or what we need to make sure, is that we choose an indicator which changes color where we have this quick change in pH. What that means is that my change in color happens with a very small amount of sodium hydroxide being added. I add 1 drop and all of a sudden my pH spikes and my color changes. If I used an indicator which changed color down here at a pH of perhaps, say, between 3 and 4, what would happen is I would need to add a lot of sodium hydroxide to change the color. I would have to go from perhaps this point here in my graph all the way and add it until I get to this point here. And I'd have a slow change in color. So what we want is a really quick change in color, and that's denoted by this really sharp change in pH range. For a weak acid and a strong base, we will use phenolphthalein indicator. That changes color around about 8 to 10. This information's in your data booklet as well. So your pH range for your different indicators is in your data booklet. But rule of thumb, if you're using a weak acid and a strong base, use phenolphthalein. Now an error, let's say I use the wrong indicator in this titration. Well, first of all, I wouldn't get a nice change in color. So if I used methyl orange or methyl red, its pH change would be in this area here. So it would be a slow change in color. But the other point of that is the change in color would happen before I reach my equivalence point. So because I'm adding my sodium hydroxide, I would have a change in color perhaps at this point here, and therefore I wouldn't add enough sodium hydroxide. What that means is it looks like I have less acid than I actually do. Again, with errors, you need to work through what the effect is on each individual case.